In space, we are still gonna need cell phones. That's why we 3D printed an induction charger rover. Let's see how I slice it. Today we are going to talk about this little guy here. This is a model from Astroflix Space Exploration Drop. You can check the link on the description. Okay guys, the files are over here. So let's first start with the name, okay? You can check the dimension of your charger over here. You have 60 millimeters and we have three more options, I think. I just checked and yes, we have three more options. And I want to show you guys something. Even if you have a different charger from these four sizes, you can use the measure, okay? Option on Prusa, and then you can check the diameter of this hole over here. So you can select something like this and then check the other side. So we have of course 60 millimeters. Almost is not so right because I should take the exact midpoint. Is going to give you a good idea from the measure, okay? And then imagine that your charger has, for example, 77 millimeters, and then you can use this as a math for calculate how much you need to increase this if you want to be at the exact size, okay? Because we have the 70 millimeters option, but if you want to do really close, then you can increase this one or reduce the other one. I recommend to increase this. So let's just imagine if you want to use 67 millimeters as a diameter for our charger, but this model has 60. So let's just divide it, and then we have 111 or 112%, 1.12 scale. Okay, let's close this one, and then we are going to increase this 112. Remember to increase all the files if you are playing with the scale. And now we just need to check the measurement like here and in here, and now we have almost 67. Okay, so this is an option. We have four sizes, I already told you, but if you have a different charger and is not fitting with these options, you can use the measurement and some math to help you to use the file, okay? Let's put this back to the right size, and then let's talk about the options of slicing, okay? First of all, let's start from the wheels, okay? By design, we put in here a support material to help you to do the whole part on this wheel, okay? But if you just slice it, you may notice that we don't have the support in here. So to improve this, we need to enable the detect thin wall options. And now you have a support by design ready to print and ready to support this bridge over here, okay? This is a small region, but if we didn't have this, let me just show you why we did this. If for some reason you forgot to put supports in here and then just print this trusting on bridging settings, we are going to have problems on this part because we are going to put filament in the air in the middle circle. Okay, so for those who don't have a good memory like me, it's better to have the supports right on the design. But now remember, you have to enable the detect thin wall options. Another recommendation, but it is just a design one, you can use the changing filament on this part over here, right in the end of the model. And then you can have a difference like a white one. You should start from black and then go to white, and then you have a cool design in here. Let's just change this color just for seeing, and then we have a white one in here, something like this. I think it's pretty cool. okay? You can use the automatic change filament option from Prusa if your printer works with it. On my printer, Ender 3v3 SE, this option works. Now let's take a look at this part over here. I am not going to print them together, and I'm about to say to you why. This one, we don't need to concern a lot. I think we do have some details in here, but I think 0.2, a standard parameter settings is just going to work fine. Okay, the shape of this print is just simple. We have a lot of content in the bed, so it's a safe print. And we don't have any detail that is extremely, I don't know, concerning. So I would recommend you to use your standard settings that you are just working on, okay? But now look at this final part that we have to print. Let me enable this. And then we do have this articulation in here, I would say. And let me slice it. So we do have an articulation in here and also some small dots that hold the position of the head, okay? But we need some tolerance in here. And depending on your settings, depending on your filament, it may change on the print. So I recommend you to test it, just this part, before go the whole print, okay? I personally like to do this because, for example, we have 4 hours print in here, but if I cut this like first in here, for example, and then let's just perform this cut, and then we do another one. I'm just showing you guys, and if you don't agree with this, you don't need to do it, but it's my recommendation, okay? Now, another time, and then another one, like this, for example. Just perform. And then, like this. Let's put this in here. And perform again. And now we can check. Let's slice it. And now we can check in 40 minutes if it's going to work. I would also remove this because it's going to be the bad part, for example. Like this, and then like this. Perform. And also, oh, I'm sorry, this in here. Now even less, okay? Oh, same 40 minutes. But I will check just the articulation and see if my settings are working. And then after that, I would go with the 4 hour sprint. It's more safer, we can save filament, and also we can play around just with the articulation, which is a important part of this print. The head holding the position is pretty nice. It's a hover, it's a robot, so this movement makes a lot cooler, okay? Well guys, those are my only recommendation. This is actually a good print to do. It's an easy one, so I hope you learned something from this video, and see you in the next one. I hope you guys enjoy it. Those slicing videos are an initiative from STL Academy, which is the educational project from STLFlix. So if you guys want to learn more about 3D printing, you could check our description and look at STL Academy courses. And don't forget, see you guys at the next slicing.